Hello everyone, I am Prasad Siddhant from NIT Raipur and I am excited to present our solution for problem statement 2 in the Bharatiya Antariksh Hackathon, an AI based help bot designed for information retrieval from a knowledge graph built on static and dynamic content from the Mosstack web portal. This is the main interface of our application built using React. The design draws inspiration from space interfaces with a clean futuristic layout meant to feel intuitive and intelligent. It focuses on three key capabilities. 1. Responsive website interface. Second, web animation of our solar system in the background and the Chandrayaan cursor. Now moving towards the chatbot section. This is the heart of our system, the AI Space Assistant. It acts as a conversational gateway to retrieve information related to ISRO mission, space data, and satellite data, and more from the hybrid backend which manages the data crawl from the Mosstack website. The assistant greets the user and invites queries related to space exploration, ISRO, and planetary data. The user simply types a question and the bot intelligently responds using the data sourced from Azure SQL, FAISS, and embeddings, and a Neo4j knowledge graph. So let's took our time to give it some questions so see its capability to handle it properly. We have given it a simple question just based on the definition. We have asked what is Scorpio is related to. See, it replied. Scorpio is related to satellite based cyclone observation and real time prediction over the Indian Ocean. Okay, let's give it some difficult questions. We have asked about all missions of Meteorological and Oceanographic Satellite Data Archival Center. C. It responded in INSAT 3D, INSAT 3DR, Kalpana 1, INSAT 3A, Megatropics, Saral, Altica, Oceansat 2, Oceansat 3, and all the other data which is properly answered by the chatbot. Okay, let's give it some more questions. We have asked a simple another definition type question that what is Vayu related to? It replied that Vayu is related to air quality. Okay, one more definition type question. C. Safe beach relates to RIP current forecast for all India beaches. So clearly we can see the efficiency of our chatbot that you can ask anything whatever you want and you feel like knowing and you can waste ton of time by not manually searching it from the Mosstack website. Also you can see the focusing on details of this cursor. This is not just a normal cursor. When you don't move it, it just floats around with its exhaust off, and when you just drag it, it becomes glowing like this. Our architecture integrates real-time NLP processing, semantic search, and graph-based reasoning, all wrapped up in a user-friendly, responsive front end. This project showcases how cutting-edge AI and space data simplify access to critical information and engage users interactively. So now we will move towards the backend to know step by step that how this application is working and how this chatbot is retrieving data from the Mosstack website. Let me give you a quick overview of how our ingestion system works for the AI help bot built on Mosaic data. Our ingestion pipeline is designed to automatically collect, clean, and structure information from the Mosaic website, both static and dynamic content. Step 1. Crawling the website. For the crawling of the website, we have made this crawler.py. We use an automated browser tool to powered by Playwright to explore and collect all the valid links from the Mosaic website. This simulates a real user clicking through the site and saves all the internal URLs into a CSV file for further processing. Step 2. Loading and cleaning content. Once we have the list of URLs, we load each page's content using LangChain tools and clean the raw HTML to extract readable text. This removes unnecessary elements like code, ads, or scripts. Chunking the data is the step 3. After cleaning, we split the long web pages into smaller meaningful chunks using the smart text splitter. These chunks are easier to process and are suitable for both embeddings and answering user queries later. Extracting knowledge triplets. Now comes the intelligent part of we use GPT-4 to extract structured facts from the content in the form of triplets, that is head, relation, and tail. See this. Here it is head, tail, and entity means relation. These triplets form the basis of our knowledge graph and help the bot understand relationships between different entities. Each of these modules is modular and works independently from crawling to chunking to triplet extraction, and together they create a clean structured database from the entire Mosaic portal. In short, this ingestion pipeline turns the unstructured Mosaic website into a machine-readable knowledge graph, making it easy for our AI bot to understand and answer queries intelligently. Now, I would like to give you a quick demo of our Python crawler.py app. You can see that our Python script started crawling Mosaic website step by step. It starts from the Mosaic homepage, visits each link up to a certain depth, filters out unnecessary links like login, mail, or JavaScript links, collects all clean URLs and save it to the URL list.csv. This ensures we don't miss any important page on the website. This uses LangChain's web-based loader to load a web page and HTML2 text transformer to clean the HTML into readable text. Let me break down how this intelligent retrieval system works step by step, powered by Azure Cloud Services, Neo4j knowledge graphs, and advanced AI models. Step 1. User interaction via React frontend. User begin by typing a query into our React-based chatbot interface. For example, show rainfall data over Orissa for June 2024. This query is instantly sent to our Flask or Fast API backend, which serves as the brain of the system. Step 2. Query understanding with GPT on Azure OpenAI. The query is passed through Azure OpenAI service where GPT-4 interprets the intent of the query. This helps us to decide which backend engine to use, whether the knowledge graph Neo4j for relationship-based queries or FAISS for semantic search across unstructured documents or Azure SQL for structured tabular data. This is what we call our query routing layer. Step 3. Knowledge Graph. Search Neo4j on Azure. If the question involves relationships like which satellites monitor sea surface temperature, the system uses LangChain, Knowledge Graph QA chain, queries our Neo4j graph database hosted on Azure or Neo4j Aura DB, extracts head relation tail triplets like INSAT3D monitors sea surface temperature. These provides accurate structured answers. Step 4. Semantic search with FAISS plus Azure Blob Storage. If the query requires understanding context from large documents, PDFs, reports, HTML pages, we use FAISS vector search backed by GPT-4 embedding hosted on Azure. All documents are chunked and stored in the Azure Blob Storage. FAISS retrieves the most relevant chunks from metadata. The response is then summarized by GPT into clean readable text for users. Step 5. Structured data lookup. For queries needing factual numeric or tabular data such as what was the land temperature over Rajasthan in May 2023, the system pulls directly from the Azure SQL database where we have stored satellite readings, timestamps, and spatial attributes. This ensures high accuracy and performance for time series data queries. Step 6. Answer generation and display. All the responses, whether from Neo4j, FAISS, or Azure SQL, are finally aggregated, passed through GPT for formatting, and returned to the user in our React UI. The frontend uses real-time streaming of answers, tagging of sources, graph or table rendering for visual outputs. Feedback and loop logging. To improve continuously, the system logs failed queries, gaps in coverage, response confidence levels. These feedbacks is analyzed periodically using Azure functions, triggering re-ingestion, re-embedding, or graph updates as needed. Azure services used in our retrieval systems are LLM GPT-4 by Azure OpenAI Service, Azure Blob Storage, Azure SQL, and Azure Functions. Now, to summarize, our help bot intelligently routes each question through the right engine, Neo4j, FAISS, or Azure SQL using GPT-based intent detection. It seamlessly integrates Azure Cloud Services for scalable, real-time retrieval and presents clean human-like answer on a fast React UI. This system brings scientific satellite data to everyone in just a few seconds, revolutionizing how we interact with the space-based intelligent system. As you can see, it started extracting triplets in chunk form and spreading it according to a relation that we told you earlier, that was head and tail and is the context. It says the ingestion is complete. So now let's verify it by opening our Neo4j Aura DB to see that whether it created a knowledge graph or not. Here we derived a cipher to check all the nodes of our knowledge graph. Okay, now we will run our query to see whether our knowledge graph is created or not. See, it created a knowledge graph. Here we can clearly see that it has created a knowledge graph linked to various nodes and edges to make it more easier for our chatbot to retrieve information when a question is asked. Now we'll move towards our chatbot, but not this time we are accessing it from our website directly, we are from our terminal. To access it from the terminal, we are running this time this main underscore chat.py so that we can see our chatbot directly answer our queries in the terminal. So let's run and see what happens. So let's ask him the same question that we asked earlier to see whether it can answer it and what really happens in the backend. It is going in the backend and saying entering new graph cipher QA chain, generated cipher, it matches with entity and then return n.name that as relationship, and it gives the full context, and the best generated answer is then presented by our GPT-4 model, and it says Scorpio is related to satellite based cyclone observation and real time prediction over Indian Ocean, as we got earlier in our main chatbot. Okay, now we are asking some different question. Again, it returns with safe beach relates to rip current forecast for all India beaches. C. We have asked which organization maintain MOSDAQ. It replied Space Application Center, India Space Research Organization and Government of India maintains MOSDAQ. So this is our chatbot and it's fully functional and scalable as we have used Azure Cloud Function so that it works automatically to we have used these numbers of Azure services fully cloud-based so that it's easier to access and scalable in the long run. And it can handle a large amount of traffic, generate billion of responses in the real time. Thank you.